Patria adalah menjalankan kegiatan perusahaan dengan standar etika yang tinggi dan bermartabat disertai dengan kejujuran dan integritas. Meningkatkan kesadaran pengguna produk geosintetik untuk memilih produk dan solusi yang tepat atas masalah proyek yang dihadapi. Menjual dan melakukan pemasangan produk-produk geosintetik yang berorientasi pada kepuasan pelanggan dengan memberikan pelayanan berupa material berkualitas dan jasa pemasangan oleh tenaga-tenaga ahli dan berpengalaman. Mengembangkan perusahaan dengan sumber daya yang modern dan profesional. Memberikan penghargaan kepada karyawan melalui kesejahteraan yang baik, penyediaan lingkungan kerja yang aman dan nyaman, serta kesempatan untuk mengembangkan karir. Produk-produk PT Multibangun Rekatama Patria. Produk Tensar System terdiri dari Geogrid Tri-X, terbuat dari bahan polipropilin berkualitas yang berfungsi sebagai stabilitas tanah dasar, khususnya pada tanah lunak. Multi-block retaining wall system. Multi-block retaining wall system merupakan sistem konstruksi dinding penahan tanah segmental, perpaduan antara modular blok beton sebagai facing dan tensor uniaxial geogrid sebagai perkuatan tanah. Geomembran. Geomembran terbuat dari polimer plastik yang bersifat kedap terhadap cairan. Kami juga menyediakan produk-produk geosintetik lainnya seperti geotekstil, material drainase, serta geosintetik clay liner yang menjadi solusi bagi proyek-proyek Anda. Gudang PT Multibangun Rekatama Patria hanya 5 menit dari gerbang tol Bitung Tangerang, sehingga memudahkan akses pengiriman material. Gudang PT Multibangun Rekatama Patria terletak di kawasan pergudangan pengembangan kawasan terpadu 2, Bitung Tangerang. Yang mempunyai luas 3.300 meter persegi yang dapat menampung material geosintetik dengan pengaturan dan penyusunan material yang tertata rapi. Serta pengoperasian alat dengan tenaga profesional. Kami pastikan material geosintetik tetap terjaga kualitasnya hingga sampai di lokasi proyek. Selalu ready stock dan pelayanan profesional adalah komitmen kami. Dengan pengalaman dan pelayanan yang teruji, maka jangan ragu untuk menghubungi kami. Kunjungi website kami di www.multibangunpatria.com.
Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah Selamat siang Bapak, Ibu, dan Sobat Multibangun dimanapun berada. Senang rasanya saya Rifa dapat hadir kembali bersama Anda di webinar kali ini. To everyone streaming from outside Indonesia, we welcome you to this webinar. For your information, this webinar will be conducted in Bahasa Indonesia, but the presentation and later the Q&A session will be in English. Webinar ini merupakan bagian dari rangkaian program Multibangun Engineering Hub yang meliputi kegiatan webinar, workshop, dan Multibangun Goes to Campus. Untuk dapat bergabung pada WhatsApp Community Multibangun Engineering Hub, Bapak dan Ibu dapat scan barcode yang akan tampil pada layar Zoom Bapak Ibu atau tertera pada chat box. Selanjutnya, tanpa berlama-lama lagi, kita akan segera mendengar presentasi dari pembicara utama kita, yaitu Dr. Andrew Lees. Sebelum itu, izinkan saya membacakan profil beliau. Dr. Andrew Lees adalah pendiri Geofem dan seorang insinyur geoteknik dengan pengalaman lebih dari 25 tahun dalam analisis numerik serta penerapan praktisnya pada permasalahan kompleks interaksi tanah struktur. Ia merupakan penulis buku Geotechnical Finite Element Analysis, dipublikasikan oleh ICE tahun 2016, dan panduan NAFEMS berjudul Obtaining Parameters for Geotechnical Analysis, serta telah banyak mempublikasikan karya ilmiah di bidang tersebut. Andrew sebelumnya bekerja sebagai insinyur geoteknik di Montreal International dan kemudian menjadi dosen teknik geoteknik di Frederick University Cyprus selama lebih dari 1 dekade. Ia berperan penting dalam pengembangan metode numerik geoteknik melalui keterlibatannya dalam evolusi dan penyusunan ulang Eurocode 7, serta sebagai koordinator ilmiah proyek Kogen yang didanai oleh Uni Eropa. Dalam beberapa tahun terakhir, fokus penelitiannya adalah integrasi data berbasis satelit dengan pemodelan numerik untuk menilai risiko bahaya geologi atau geohazard terhadap infrastruktur. Demikian profil singkat dari pembicara kita pada hari ini. Baik, Bapak Ibu, apabila ada pertanyaan selama dan setelah presentasi berlangsung, dapat langsung menggunakan fitur Q&A yang terletak di bawah layar Anda. Pertanyaan harap disampaikan dalam bahasa Inggris ya. Pastikan Bapak dan Ibu tetap bersama kami sampai akhir acara, karena seperti biasa nanti akan ada kuis berhadiah yang pastinya jangan sampai dilewatkan. Simak keseluruhan presentasi karena pertanyaannya akan seputar presentasi dari para pembicara kami pada hari ini. Alright, Dr. Andrew, are you ready? Alright, without further ado, ladies and gentlemen, please welcome Dr. Andrew Lees of Geofem.
Okay, thank you, Rifa. You can activate my video so that people can see me.
Sure. Let me wait a minute.
Okay, there I am. So, hi everyone. Thank you for joining us today for this webinar on using satellite data and AI to identify geohazards generally, but we're going to have a focus on sinkholes. So let's get underway. Okay, so you should see the title slide now of the presentation. So title, Identifying Sinkhole Precursors and Assessing Collapse Risk Using Satellite Data and AI. It's our pleasure to present this webinar in Multibangen's popular webinar series. A bit of background to Geofem, the company. As was said in the introduction, my background is in geotechnical finite element modeling. So I set up the company Geofem to perform exactly that, GeoFEM. And we've been doing that since 2007. But about 12 years ago, I saw the potential for satellite data use in geotechnical engineering. So that became a major part of Geofem's technology as well. So thanks to our partnership with the European Space Agency, we have developed a lot of technology, particularly in assessing geohazard risk that I will present in today's webinar. So that's just a bit more background to Geofem, summarizing what I just said, more or less. So we're a leading provider of innovative Earth observation, GIS, and remote sensing solutions, all complemented by our background in geotechnical engineering. So that helps us to interpret the data and validate it. It also helps us to develop new applications of satellite data specifically for geotechnical applications. So we'll see those later on. We're based here in Cyprus, but because of the nature of our work, we are able to and often do work on projects located all over the world, right from the Americas to New Zealand and including Indonesia. And I have a couple of examples to show in Indonesia during the presentation. So what we're going to cover today is, first of all, displacement measurement by satellite by the technique INSAR that many of you will have heard of. We will look at some examples. Then we will look at the main topic of the webinar, which is detecting sinkholes. So sinkholes are a common geohazard in Indonesia. It would be useful if we could detect sinkholes before they occur so that measures can be taken to avoid too much damage and certainly to avoid injury and loss of life. We will then look at the next stage, which is to use INSAR in combination with other data to assess the susceptibility to a geohazard. So not just detect movements, but to use all the parameters, including movement, to identify areas that are at higher probability of experiencing a geohazard. And then we will look at how we can map sinkhole risk using that approach. So first of all, we will look at displacement measurement by satellite. That has become possible due to something we call the SAR satellite revolution, which is a different type of satellite that you may not be familiar with, that allows these measurements to be taken by satellite. So if you use Google Maps and you select the satellite view, you get an optical satellite view that you can interpret with the naked eye. SAR satellites are different. You cannot interpret them manually with the naked eye. That is because SAR is radar. SAR stands for synthetic aperture radar. So we are all familiar with radar that is used in for shipping and for navigation at airports and so on. So radar involves emitting an electromagnetic pulse and detecting reflections or backscatter that return. So SAR satellites operate in the same way. They emit a pulse and they detect the backscatter that comes back. Now, the word aperture is another word for the antenna, and this is the device that transmits and receives the electromagnetic energy. The bigger that is, the better the spatial resolution. Now, the spatial resolution is a measure of how many data points you get across a unit area. So the better the spatial resolution, the closer together the data points are. So data points could be as little as a meter across, or they could be several hundred meters across. So the bigger the aperture, the better the spatial resolution. Now, to get a useful spatial resolution, the aperture would need to be very big, hundreds of meters or kilometers across. That's not practical on a satellite. So what the satellite does is synthetically, it creates a larger antenna. And it does that by taking a sequence of acquisitions from a smaller antenna. So by combining those acquisitions together synthetically, it creates the effect of a very large aperture, and that improves the spatial resolution. So for example, with the Sentinel-1 SAR satellites, that's the data that we will look at quite a lot today. That has a spatial resolution of about 10 meters by 10 meters. And that's a good practical level to measure the displacement of geotechnical structures and for assessing geohazards that tend to occur over quite large areas. The big advantage of SAR is the portion of the electromagnetic spectrum where it operates. That's in microwave and radio wave. That means that it's unaffected by cloud cover. So that's going to be very useful in Indonesia, where there is frequently cloud cover. That is always the drawback with optical satellite images. Every time you get the image back and all you see is cloud, then the image is useless. And you have to wait for the next image and keep waiting until the satellite obtains an image where there are no clouds. Well, with SAR, you don't have to worry about that. It sees straight through clouds. It even operates day and night. So it is a very reliable source of data. So each time the satellite passes over, typically about every 6 days, you will obtain data, almost certainly. Now, the orbit that the SAR satellites operate in is in a polar orbit. It's called a sun-synchronous near-polar orbit. So this video shows, speeded up, the orbit taken by the Sentinel-1 satellites owned by the European Space Agency. And you'll notice that the satellite keeps orbiting in the same plane, but the Earth rotates beneath. And in fact, the satellite will slowly rotate around so that it remains in the same orientation to the sun. So that's why it's called a sun-synchronous orbit. The advantage of that is every time an image is taken, let's say an image is taken from Indonesia here, every time that image is taken, the sun is in the same position in the sky. And that helps to eliminate one variable from a time sequence of images. So if we were taking SAR images, and in every image it was morning and then evening and then midday and then the middle of the night, you've got that variable. So although SAR still works in different times of the day, you may have thermal effects, for example, and different levels of solar radiation that are going to affect the accuracy of your results as you process that data in image after image. So that's why it is a big advantage to have a sun synchronous orbit. And you'll see from that video how you get complete global coverage with the Sentinel-1 satellites. So with the Sentinel-1 satellite, we have global coverage about every 6 days, sometimes every 12 days. A lot of optical satellites will look directly down in what is called a nadir view. SAR satellites look to one side, normally to the right in the direction of travel, in what is called an off-nadir view. And that is essential for SAR satellites to operate in that way. Some of the commercial satellites are able to point in different directions, while others are fixed in the orientation. So the Sentinel-1 satellite is fixed. Because the satellite is orbiting pole to pole, you can obtain images from two different types of orbit. Imagine we have an area of interest here. So we want to obtain SAR images for this location to obtain some data. The satellite may be traveling from south to north in what is called an ascending orbit and looking to the right and downwards and acquiring this image here. So we could obtain images from that orbit in pass after pass and obtain a time series of images from an ascending orbit. But in many locations, there are images also available when the satellite is traveling from north to south, called a descending orbit. The satellite is still looking to the right in the direction of travel and downwards, and we can obtain images pass after pass in a descending orbit. So this is called a descending image, and this one is an ascending image. And it is possible in many locations to obtain data from both. And that will become important later when we look at displacement data, because the displacement that is measured is in the line of sight of the satellite. So in an ascending orbit, when the satellite is looking downwards and to the right, the displacement is in that direction. So a positive value of displacement would be upwards and to the west. And a negative value of displacement would be downwards and to the east. And conversely, in the descending orbit, if we process a time series of images in the descending orbit, a positive displacement will be upwards and to the east, while a negative displacement will be downwards and to the west. If you have both sets of orbit, it is even possible to combine the data to true vertical and horizontal east-west. That's a bit like resolving forces in a free body diagram. You resolve them into two orthogonal directions. So it's the same here. We have displacement that direction, displacement in that direction. If we combine the two together, we can obtain, instead of those two line of sight directions, we can obtain vertical and horizontal in the east-west direction. So we will look at some examples later. So when we download data or images from SAR satellites, what exactly is the data that is recorded? Well, remember, it's recording the backscatter or reflections of the radar wave going back to the satellite. So if we imagine that these are signals that are received, this is the radar signal received back to the satellite on two different passes. One parameter that is measured is the amplitude of the wave. That depends on a number of factors concerning the Earth's surface and textures. And it depends, among other things, on the dielectric constant of the soil. Higher dielectric constant means higher amplitude. And because the dielectric constant of the soil depends on moisture content, it is possible to determine the moisture content at the surface from the amplitude. And we have developed an algorithm that will convert that amplitude combined with other data to obtain the moisture content. And as any geotechnical engineer will tell you, knowing the moisture content of the soil is very important. Most triggers for geohazards, such as landslides or sinkholes, occur due to raised moisture content. How often have we heard about a major landslide that has occurred after heavy rainfall? So that is why the moisture level is very important. So we're not going to look at soil moisture anymore in this presentation, but it is useful to know that it is possible to measure that by satellite. The other parameter that is measured is the phase of the wave. And if between passes of the satellite there is a change or a phase difference, then that can be converted into displacement. So let's look at how the displacement measurement is undertaken in simple terms. Here is our SAR satellite, and it emits an electromagnetic pulse, and it receives backscatter from objects on the Earth's surface. Let's imagine that this building reflects back the radar wave as this blue wave, and that is received by the satellite. and the satellite records the phase and the amplitude of that wave. The satellite continues on its orbit, and it returns 6 days later, emits an electromagnetic pulse from the same location, receives backscatter again from the same building, this time the red wave, back to the satellite, and it records the amplitude and phase. But in between the passes of the satellite, this building has moved. So a displacement is detected. And that is detected not from the change in distance from the building all the way to the satellite, but it is detected because there has been a phase shift in the wave because of the changed position of this source of the backscatter. So with a wavelength of typically a few centimeters, if you can detect a phase change, you can detect displacements at the sub-centimeter level. So the process to obtain displacement involves creating an interferogram, and that is essentially the difference between two SAR images. Now, another source of difference is the effect of topography. So you need to correct for the topography of your location. So that is the shape of the land and where all the hills and the slopes are and the height of the ground. So with a separate digital elevation model that has the topography, you can correct for that, which will leave the displacement between the two images. And that process is called differential interferometric SAR, or DINSAR, or often called INSAR without the letter D, but they mean the same thing. So you can produce a displacement plot with centimeter level precision from just two images in an interferogram. So these are commonly used after earthquakes. So with earthquakes, you have a sudden large movement. So you want to compare the SAR image from before the earthquake with after the earthquake so that you can see the amount of movement. And the output produces these colored fringes which show movement. And because the movement has been so large, it is actually the phase difference is the multiple wavelengths. So this is suited to large sudden movements. But in most geohazards, they develop as initially slow, gradual movements, and maybe they will accelerate. But if we want to predict when a geohazard is going to occur, it's not going to occur, it's not going to give you a warning with a huge movement like this. That is when the geohazard has already been triggered and you have a large movement. We are interested in detecting those small movements that occur as a landslide initiates or as a sinkhole occurs. You expect to see slow movements leading up to the collapse. To detect those, we need a more accurate method than this centimeter level precision. We do that by going a step further with INSAR to do time series INSAR. In time series INSAR, instead of one interferogram between a pair of images, we are looking at multiple interferograms between a time series stack of images, usually at least about 20 images are used in time series INSAR. Now, by looking at a time series such as this, you can improve the corrections for atmospheric effects, residual topographical errors, and other errors. Persistent scatterers are identified with adequate amplitude and high coherence across multiple images. So what that means is, across all these images, the analysis is looking for objects that are providing a reliable, persistent signal or scatter or reflection of the radar. So if it sees a good amplitude and a consistent signal that's the same time after time, it knows that that is a reliable source of data, and that should give a reliable displacement measurement. So examples of scatterers that are not persistent or have low coherence is an agricultural field, for example. So the ground is plowed and you have bare soil, seeds are planted, the crops grow gradually, and then they are harvested and cut down. So you are having textures that are changing all the time. So that means each time the SAR satellite takes an image, it's getting a different signal. So it realizes that that is not an accurate source of data to use for displacement. So that data is removed from the analysis. So we will see an output later where we get some gaps in the data. And the reason for those gaps is to remove the unreliable data. Another example is thick forest cover. With certain wavelengths of SAR, you will get reflections off the tree canopy. And that again is not a persistent scatter. It keeps changing. With longer wavelength SAR, the waves can penetrate through the forest and you get reflections off the ground surface. So with this time series method, you can obtain a much improved accuracy of about 2 to 4 millimeters. So there have been many studies to demonstrate this accuracy by comparing the displacement data with known displacement values measured in situ on the ground. And we also have many examples where we have undertaken INSAR analysis and we have monitoring data on the site from survey measurements or from sensors, and we compare the data with each other. So we have many examples where we have validated this displacement accuracy. So let's look at some examples. So this example is used to show how INSAR displacement measurement is excellent as a screening tool to monitor large numbers of structures. So this bridge in Dresden in Germany carries a light rail on this side, and there's an adjacent bridge that carries a road on the other side. Now, without warning, in September 2024, this bridge collapsed. Fortunately, it happened at night, so there were no casualties. But it could have been much more serious. Now, this happened by surprise, and there was no data indicating that there was a problem with this bridge. So we undertook INSAR displacement analysis retrospectively to see if the data could have foreseen that there was an issue with this bridge. So here we have an optical image of Dresden. You see the river, and we have three bridges here. This is the bridge on the left-hand side here that collapsed. So I will present INSAR displacement data over this optical image that you see here. So this is usually how INSAR data is presented. All these points represent displacement measured over the analysis period. And so in this example, it is over 2 years prior to the collapse. And it is presented on an optical image so that we can see where these points are located. So these points are from the Sentinel-1 satellite data. So that is freely available data, and it has a spatial resolution of about 10 meters by 10 meters. So these points that you see are about 10 meters apart. The big advantages of Sentinel-1 data are that it's free, so it's very cost effective to check the condition of infrastructure, such as bridges, and for monitoring geohazards. The other big advantage is that this data has been acquired since 2015. And that data has all been archived. So it is available to download for anywhere in the world. So for any site that you are interested in, there is already 10 years of data about every 6 days so that you can see how infrastructure has been performing for the past 10 years. That is very useful when you interpret the data that you are getting today, if you can see what's been happening in the past. It also allows us to go back in time and to look at the data prior to a collapse, such as this bridge. You can see from the legend here that green colors indicate very small movements of about -2 to +2 millimeters per year. So most of the area is green. We get occasional yellows indicating movement away from the satellite in the line of sight direction, and blues indicating movement towards the satellite. So small movements are noted on these two bridges, but clearly there is a problem with this bridge. We are getting several points that are orange, indicating movement away from the satellite, probably a downward movement of the bridge, and even blue upward movement of this span. This is indicating that this span is moving down while this span adjacent is moving up. There is enough information here to highlight this as a problem bridge. Had this information been used, this could have alerted the local authority, and they could have investigated the bridge further by undertaking surveys and installing sensors on the bridge and identifying what was the cause of the problem. It is possible that the bridge could have been fixed to avoid the collapse, and the bridge could have been closed to avoid the risk to users of the bridge. It was only sheer luck that meant that there were no casualties from this bridge collapse. So here's an example from Indonesia, Batu Raja in South Sumatra. Imagine that we wanted to monitor the hundreds of bridges located across Indonesia. That would be a big task to do manually by visiting each bridge to survey or to install sensors. But with INSAR, It's very easy to go back in time. Here, we've gone back 5 years to plot the displacements in the town and also across the bridge. So we've obtained multiple points on the bridge. The good news is the points are all green, indicating no known issues with this bridge. And we can plot some of these points and we can see that we get some noise in the data that could be real displacement due to thermal effects or maybe due to loading as well, but no accumulation of displacement. So you see how easy that was just to make an assessment of that bridge. Now, that's no guarantee of safety, of course. The bridge should still be inspected, but maybe it can be inspected less often with the benefit of this data. And if the bridge was indicating movement, then that could be inspected more often. It just means better allocation of resources. Now, this is a webinar for multi-bangan, so I had to include some GeoGrid examples. So here is a mechanically stabilized earth wall or reinforced soil wall installed for the Dubai to Fujairah freeway in United Arab Emirates. It's the tallest MSC wall supplied by Tensar, up to 70 meters tall, constructed in 3 tiers. So a huge structure that is well suited to monitoring by satellite with the Sentinel-1 data and its spatial resolution of 10 meters by 10 meters. So here's an optical satellite image from above looking at the freeway, and the freeway passes over an embankment here. So you can see the slopes of the embankment on each side. So we have green colors indicating no movement on the highway as it passes through the rock cutting. And then when it goes onto the embankment, we are getting some settlement that you would expect from such a high embankment due to ongoing consolidation, maybe creep movements of the embankment slope. So if we plot one of these points over here, you can see a steady rate of settlement of the highway of about 25 millimeters over 4 years. So nothing too alarming, but it just demonstrates how easy it is to obtain this data and how useful it is to monitor the condition of assets. Now here we have the MSC wall with its multiple tiers you see to the side, and here is the freeway going along the top. We're getting green points everywhere. If we plot one of those points, we can see, just like the bridge in Sumatra, we're getting a little bit of noise, perhaps due to thermal effects, but overall no accumulation. And in contrast to the embankment where you still get noise, but clearly an ongoing accumulation of displacement. Here's another tensile structure, this time in India. This is a new reinforced slope to support this road following a landslide that occurred and where the road was lost down the slope. And it was developed into an attractive feature as well, with the stream allowed to flow through the middle. So after construction, we undertook an INSAR displacement analysis to monitor the displacement of the reinforced slope as well as the road that was constructed at the top. So we obtained a number of points we can plot that data, and we can see that over the analysis period and in about the 18 months following construction of the wall, we had no accumulation of movement. And that's what we want to see. So the reinforced slope is performing well. Now, when we do an INSAR displacement analysis, we select quite a large area. So even if it is just that one site we want to measure, it is normal practice to select a larger area. So this is the retaining wall or the slope located here, but we obtain data very easily across a large area. You get gaps in the data, as I explained before, if it is not getting a reliable signal, perhaps due to vegetation with the Sentinel-1 data operating in the C-band, it will not get reliable data when there's thick vegetation. We need to change to L-band and the free NISAR satellite to obtain data of ground movement in heavily vegetated areas. We zoom in a bit, we can see very easily areas of movement, and this really highlights INSAR as a screening tool to assess the risk of geohazards. So there's something going on here. Green colors in most areas, but just an area of concern there. So if we zoom in to this area, plot the data, we can see that over a year it moved about 20 millimeters. So this was not part of our project, but it illustrates how it can be used as a screening tool. And so we pointed this out to the client, that maybe the local authorities need to be informed that there is a potential risk to this area of housing here. Now, we have another example looking at active faults. That's very relevant to Indonesia. This work was undertaken for the rail company in Turkey, where they were experiencing regular ongoing movement of a rail track in the Konya area of Turkey. So we undertook INSAR displacement analysis from 2018 to 2024 using the historical archive data. This is the rail line running southeast to north, southwest to northeast across this optical image. And you can see from the INSAR output where we have in greens over here indicating no significant movement. But as we move east, we go from yellow to orange to red, indicating increasing movement away from the satellite, probable downward subsidence. Clearly, there is an active fault zone here, and that explains why the rail line crossing this fault zone is experiencing ongoing movements. So this data really helped to explain the source of those movements. Now, let's have a look at sinkholes, another common geohazard in Indonesia. Now, let's look at the typical way that a sinkhole will form. So they tend to occur when we have rock that is soluble at depth below the surface. So a very common rock type that is soluble and forms cavities is limestone. So as slightly acidic rainwater falls and seeps down through the upper layers, you can get gradual dissolution of the limestone and formation of cavities. Now, these can take tens of thousands, hundreds of thousands of years to form. It's a very slow process. So although a sinkhole is a sudden event, the source of the sinkhole takes a very long time to form. But gradually, these cavities will grow in size and until it becomes something very large that probably we don't know about. When we are at the surface, we don't see these holes or cavities forming. Gradually, the overlying layer will fall in due to gravity. We still might not notice anything at the surface, although it is likely that there are small ongoing settlements or subsidence of the surface here that will go unnoticed to the naked eye, but may be detected by INSAR displacement. So INSAR displacement can detect movement of just 2 to 4 millimeters. So if we see settlement accumulating of about 5 millimeters and 10 millimeters in an area, that may go unnoticed by people living and working here, but will be detected by INSAR and could be a sinkhole precursor. What that means is it is giving warning that a sinkhole is going to occur here. So the sinkhole happens when finally the surface collapses down into the hole because it has lost all support beneath. So if you are at the surface and you did not know about this cavity, then it comes as an awful surprise when the ground surface suddenly collapses into this giant hole. And it is a very shocking event to occur because it comes completely by surprise. And it often happens during heavy rainfall or where there are other sources of water. Because when there is water in this surface soil here, it becomes heavier and weaker. So it is less able to support its own weight and it is more likely to collapse. So it is another example of a geohazard that can be triggered by moisture, which is why it is very good to monitor moisture as well as displacement. So we will look at an example of where we can detect these precursor movements by satellite. So one area that is probably more susceptible to sinkholes than anywhere else in the world is the Gauteng province in South Africa around Pretoria and Johannesburg. So large areas of limestone and many cavities beneath, and they have many sinkholes in this area. So we worked with the University of Pretoria to investigate the use of INSAR to detect um, uh, sinkholes before they occur. Now we use the freely available Sentinel-1 data. So that has a spatial resolution of about 10 meters by 10 meters. So to detect a sinkhole, it needs to be relatively large to detect that movement. So very small sinkholes may not be detected with Sentinel-1 data. You may need to go to commercial data, but then the technique becomes quite expensive. So we did identify one example. So here we have plotted the data. Instead of dots, we have combined it into more like a contour plot or a heat map. So the green is indicating no movement. The yellow is indicating subsidence. And you see here that there is an area showing clear subsidence here. Now, this is a precursor to a sinkhole. So number one, we know that we are in an area that is prone to sinkholes due to the geology. So it will only be a sinkhole if you're in an area that is susceptible to sinkholes, either due to the geology or maybe due to other activities such as mining or even tunneling that is ongoing. And because of its shape, sort of approximately circular, so we're not looking at a linear feature. It is something that is forming in a concentrated way. So if we plot a section line across there and look at the data, we're clearly seeing increasing subsidence towards the middle. So these were all signs that a sinkhole was developing. And sure enough, in the image shown here, this is a street view image, and eventually a sinkhole did occur at the surface. So its surface manifestation was actually quite small, but you can see from this data that the subsidence stretched from one street to the next. So all the buildings around here were at risk in spite of just this surface manifestation here. But once it does appear at the surface and the local authorities are aware of it, then they take measures to fill the hole to protect the surrounding buildings. So let's look at an example from Indonesia. Let's look at the Pondok Balik in Aceh. I've put sinkhole in inverted commas. I will explain why shortly, but here's a video from Google that I've obtained, and you see the scale of this sinkhole, and it's taken out the road here, and still water running there. It would be a good idea to stop that. This has become well known because it's gradually spreading and spreading, and you see that it's now taken out a road here. Let's look at some historical optical images that you can obtain from Google Earth. If you go back to 2015, you can see there's this feature here. And if you look from image to image in time sequence, you can use this road here as a reference point. So the road is in the same position in each image, but you can see how gradually this hole here is migrating southwards towards the road. It's a bit closer here. And in 2021, it's migrated to here. And in 2025, it's migrated a bit further, 1st of June 2025. And according to the video I just showed, it's now reached the road, and part of the road has collapsed. So it looks like it's actually accelerating towards the road. So we've seen a more rapid advance in just the last few months. So that may be due to weather conditions in the area. If there has been more rainfall than usual, you would expect this to advance more rapidly. So the reason I put sinkhole in inverted commas, that's because it's debated about whether it is actually a sinkhole. So sinkhole is quite a broad term, meaning that the ground surface collapses. So yes, the ground surface here is collapsing, and you can see it's migrating gradually towards here. But it's not the mechanism that I described on the earlier slide, where a cavity is forming due to dissolution of the ground, because there's no limestone here. So it's not collapsed due to the formation of a cavity below the surface. This is more like a landslide that is progressing gradually backwards. So think of this as the scarp slope of the landslide, and there's just collapse after collapse after collapse, and landslide after landslide is resulting in this gradually migrating southwards and has taken out the road. So the reason the collapse is very sudden is due to the geology here. These are quite recent pyroclastic flow deposits called tuff, Tuff. They're quite recent, very loose, not very well compacted or cemented. So they tend to collapse very suddenly, a type of collapsible soil, until you get the harder igneous rock geology below. So that's why it is behaving like a sinkhole, because of the collapsible type of soil, that it is just collapsing quite rapidly. And of course, if there is heavy rainfall, that is going to hasten the collapse. And we're also in agricultural fields. These may be irrigated as well. That's adding more water uh, uh, to the ground. And we saw in the video a pipe with water flowing into the hole as well. And that's all going to contribute to the collapse. So we undertook INSAR on this example here, this well-known collapse and sinkhole, to see if we can get any additional information about how this is behaving. So in this area, we obtained images from both a descending and an ascending orbit. And so it's interesting to look at how to interpret such images. So this one is from the descending orbit. So we have a satellite that is passing from north down to the south, and it is looking downwards and to the west, down into this hole. So we get points along here. What's interesting is we get no points in this area. So you do get a shadow effect. Because of this very deep hole, these SAR waves are looking in this direction, so they can see this area. We're not getting displacement because this is an agricultural area, so it's not getting reliable data from the field here. But the SAR wave passes over the top here and then into the hole, so we do get this shadow effect. So blue colors are indicating movement towards the satellite, so that's either upwards or to the east. So we're getting blue colors on this side of the hole, suggesting that we're getting landslide type movement towards the middle of this feature. So if I plot the data of P1 and P5, that's on the other side. So we're getting negative movement. So that is movement downwards and to the west. So remember, the satellite is looking downwards towards the west into the hole from the right-hand side. So P1 and P5 are moving downwards and to the left. So on this side, they're moving towards the center. If we look at points P2, P3, and P4, you see that now we're getting positive movement, which is movement towards the east or upwards. We think it's unlikely that the ground is moving upwards. It's more likely that it is moving due to mass movement, an ongoing landslide that's moving towards the center, and gradually the material is being carried away by the water flow along the ground here and eroding this channel. If we now look at ascending orbit, so now the satellite is traveling from south to north, upwards on the image, and it's looking towards the right. It's interesting here that we have a big shadow in this area. So as the satellite views downwards and to the right, it looks down into the big hole, so it casts a long shadow, and we get data over on the right-hand side of the hole. And if we plot the data P6, 7, 8, and 9, we're getting movement in the positive direction. So that means movement towards the satellite. So that is upwards and to the west. Again, we think it's unlikely it's moving upwards, so it's being caused by migration of material from this side of the hole down towards the middle, and then it's being carried away in this stream. And also in both the ascending and descending orbits, we notice an increase in activity in mid-2025. So not much was happening in this area before then, and then an increase in activity. And we saw the same in the descending orbit. And that corresponds with the historical optical images that I showed, which appear to show an acceleration of this hole southwards in 2025, in the second half of 2025. So that corresponds with this increase in activity. So it shows that if you were monitoring this remotely using INSAR and you notice this increase in activity, that might tell you that these landslides are happening, they're becoming more active. So we should expect more rapid migration of this hole. And that is indeed what happened. So it's a very interesting case study from looking at the changes in trends to identify an acceleration of a geohazard, and also how to interpret ascending and descending orbits. Now, normally we would combine this data into true vertical and horizontal, but because of this shadow effect, we don't get many points in the same place. So to combine data into vertical and horizontal, you need to have points from both orbits that are close enough together to be able to combine them into something that is going to be accurate. Now, let's look at how we combine INSAR data with other information to measure the susceptibility to geohazards. So this is technology that we have been working on to go a step further than INSAR to look at geohazard susceptibility. So from satellites, we can obtain displacement data by INSAR. I mentioned earlier that we can obtain soil moisture data, which is a very important indicator of when a geohazard is going to trigger. We also obtain topographical data by satellite and also vegetation and other factors. We can combine that with information such as geological maps and also existing data about where landslides have occurred, where sinkholes have occurred. They all help to train algorithms using artificial intelligence together with our own engineering know-how, just to validate the outputs and to check that that these AI techniques are going in the right direction to measure the susceptibility to various geohazards. This is really useful for covering large areas to assess geohazard risk. So geotechnical engineers can't be everywhere. If you need that interpretation by a human being, geotechnical engineer, they need to go everywhere to look at this data. Or if it's satellite data, they'll be looking at this data for the rest of their lives. What's great about these algorithms is they can do that initial screening across large areas. So imagine covering the whole of Indonesia just to do an initial assessment. That will highlight the problem areas where human being expertise and geotechnical engineers can go and do deeper assessments and focus resources in those problem areas rather than trying to cover everything. So these are the geohazard types that we have included so far in these algorithms. That's landslides, expansive clays, sinkholes, coastal erosion, and landfills. So to illustrate how it's developed, in this case for landslides, we did one example in California. That's where there is an existing California Geological Survey landslide susceptibility map. This is developed by more conventional means. It's a rather static tool in that it doesn't change year by year until there is a revised assessment. It's a more manual process. So we use this map to help train and validate machine learning algorithms to process all the data. And it produced this map that looks similar to the static map on the left, but it has several advantages. One is it's more granular. So the pixel size is, when based on Sentinel-1 data, is 10 meter by 10 meter. So you get a landslide susceptibility property by property at a very granular level. The other advantage is that it is based on up-to-date data. So it is using INSAR data that is showing actual movement. And it is based on soil moisture data. So it's showing up-to-date the moisture level. So it can identify where slopes have higher moisture than they had in previous years. So it might identify more irrigation. It might identify a leaking water pipe or broken drainage. Or a common problem in California is forest fires. When fires burn off a forest, a slope is then left more exposed to rainfall. The moisture level increases and it is more susceptible to landslide. There have been many landslides in California that have occurred after forest fires. So this map on the right will update in response to new satellite data showing loss of vegetation and raised moisture levels. So a much more dynamic tool. So this has been peer reviewed and published in this journal, the development of that landslide algorithm, and that was nominated for a ground engineering award last year. So we've extended this technique to sinkholes. So we undertook a study in Florida, another area susceptible to sinkholes. There have been some very high profile cases lately, even involving the collapse of a building. The reason we selected Florida is because there was data available of the causal factors of sinkholes in limestone areas. So we selected 3 areas of interest. So we used the INSAR data to check for precursors, so those initial subsidence movements, but also combined it with other information that are associated with sinkholes. So that is the geology, of course, the pH of the soil. So the more acidic it is, the more cavities you are likely to obtain. Precipitation is a factor because, of course, that's a trigger for sinkholes. And flow accumulation. That means when it does rain, where does the water flow to across the surface and where does it accumulate and eventually enter the infiltrate the ground? That is also where you are likely to get cavities forming and sinkholes. So these are all the causal factors of cavities and sinkholes. So just like with the landslide case, we used examples of known sinkholes to help train the algorithm, and then we tested it. So what I'm showing here in the 3 areas of interest are where we tested the algorithm. So the white squares are indicating where the algorithm calculated no susceptibility to sinkholes. This is in spite of the whole area being an area that is notionally susceptible to sinkholes because it is limestone. Now, areas with darker oranges and reds are indicating areas prone or susceptible to sinkholes. And these blue triangles are locations where sinkholes occurred historically, as recorded by Florida Geological Survey. Now, the algorithm did not know the locations of these previous sinkholes. It has calculated it on its own. And you see the number of points here and the darker and darker oranges. It really wanted to highlight these areas as prone to sinkholes. So it's good validation of the technique. It certainly works well in the Florida area, and these algorithms could be adapted to be used in other areas. So it's an excellent technique to combine INSAR, which may detect the precursors, but to look at other factors as well, to do a more complete assessment of where sinkholes are likely to occur. So let me wrap up by just summarizing the advantages of satellite monitoring. Now, before I do that, I am a geotechnical engineer, as you may know. So I do appreciate the value of other data, in situ data. There's no substitute for going to these sites, for seeing it with your own eyes, doing surveys on site, and installing sensors and getting data. So I never propose satellite data as an alternative. We can't do everything by satellite. But on the other hand, we can't install sensors and do surveys everywhere either. We need satellites to do that broad brush coverage, to do the screening, so that we can identify the problem areas, get more information, particularly the historical information, and help us to decide where we focus our resources and do the in situ surveys. So the reason we should use satellites is because they are very cost effective, particularly with the free Sentinel data. You may think satellites, high technology, must be expensive, but actually it isn't, particularly with Sentinel-1 and now the NISAR free satellite data with L-band SAR. It's very fast to do. It's more accurate than many conventional techniques. We get data at high frequency about every 6 days. It's entirely non-disruptive, so you don't need to stop any infrastructure corridors, for example. The processes are automated, and for me, the biggest advantage is that 10 years of archived data. So for any site, you can go back and see how trends are changing. Due to climate change, we see things changing. Slopes that were not susceptible to landslide before are now susceptible because of more weather extremes. Sinkholes are occurring more frequently due to the heavier rainfall. So we can see those changes and trends in the historical data. So if you're not familiar with satellite data, it's good to learn more about it, because now you have a whole new and cost-effective source of data to measure displacements and to measure surface soil moisture content. And it's all available retrospectively to assess historical trends. And you've seen how we can combine that with other data to assess geohazard susceptibility and improve our resilience to climate change. And we can do that by producing dynamic, updated geohazard maps, so we can predict where geohazards are going to occur in response to the most up-to-date conditions due to changing climates and changing weather conditions. So that brings me to the end. So I think later on there'll be a Q&A session, so I'll be very happy to answer any questions that you have. In the meantime, I'll pass you back to Rifa and Multibango.
Well, Thank you, Andrew, for a very excellent presentation. Since it's happened recently, it is kind of a very hot issue, Andrew, and then it's very interesting. Thank you very much. Before continue to the Q&A session, actually, please give me a presentation about the marketing materials for a few minutes. Baik, Bapak Ibu, Andrew, please stop share screen and I will share screen.
Sure.
Thank you.
There we go. Dwi.
Baik, Bapak Ibu, mungkin sudah terlihat share screen-nya. Izinkan saya perkenalkan diri dulu. Saya Dwi Agrina, Bapak Ibu. Dalam hal ini sebagai perwakilan dari marketing team untuk menjelaskan terkait produk dan jasa yang Multibangun tawarkan, Bapak Ibu. Jadi topiknya adalah aplikasi geosintetik dan monitoring jarak jauh INSAR. Baik. Untuk outline-nya sendiri, saya akan menjelaskan beberapa poin yang terlihat. Untuk tentang dari PT Multibangun sendiri, Bapak Ibu, kami adalah spesialis dari produk-produk geosintetik, ada geotextile, geomembran, dan geogrid, di mana semua produknya itu ready stock, jadi Bapak Ibu tidak perlu khawatir terhadap ready stocknya kami. Lalu kami juga berpengalaman dalam ratusan proyek yang sudah dikerjakan di seluruh Indonesia sejak tahun 1998, Bapak Ibu. Nah, untuk produk dan jasa sendiri, mungkin bisa terlihat ini adalah ilustrasi dari keseluruhan produk dan jasa yang kami tawarkan, di mana untuk dinding penahan timbunan kita punya Cerascape, ada untuk multi-block dan lain-lain. Lalu untuk geotekstil sendiri untuk pelapis atau kita untuk proteksi dari geomembran sendiri. Lalu yang terbaru nih Bapak Ibu, kami juga ada satelit monitoring menggunakan INSAR di mana kami berpartnership dengan Geofem. Baik, saya akan izin untuk mempresentasikan satu persatu terkait produknya. Untuk jenis geosintetik sendiri, Bapak Ibu, mungkin Bapak Ibu sudah sangat familiar ya. Ada geotekstil non-woven, ada geomembran, ada geogrid uniaksial, ada geogrid triax, dan geogrid interax. Ini akan sesuai dengan kebutuhan proyek dari Bapak Ibu sendiri. Untuk geotekstil, sebenarnya fungsinya mungkin Bapak Ibu sudah tahu juga sebagai separasi atau filter antara dua lapisan tanah ya. Jadi selain itu filtrasi pada material drainase ini sering banget digunakan untuk beberapa proyek. Untuk pengalaman proyek dari PT Multibangun sendiri, Bapak Ibu, untuk geotekstil, kami pernah untuk di waduk pabrik kelapa sawit Kendari nih Bapak Ibu, untuk geotekstil sendiri. Nah, ini untuk proteksi geomembran juga. Lalu untuk di Doho Airport, juga kita supply geotekstil, ini di Kediri, Jawa Timur. Lalu untuk geomembran, fungsinya sebagai kita ketahui untuk separasi lapisan kedap cairan ya Bapak Ibu. Lalu ini biasanya kita gunakan untuk kolam buatan atau kolam limbah. Jadi fungsinya agar tidak terkontaminasi. Nah, ini beberapa foto-foto yang sudah PT Multibangun kerjakan. Selain itu, juga dapat digunakan sebagai pelapis atau liner pada esyard atau koyak, Bapak Ibu. Nah, untuk pengalaman proyek sendiri, untuk geomembran, itu untuk esyard di PLTU Pangkalan Susu di Sumatera Utara, kami pernah supply. Lalu untuk kolam limbah pabrik kelapa sawit, untuk geomembran sendiri, ini di pabrik kelapa sawit Nunukan, Kalimantan Utara. Di mana memang untuk kolam limbah, Bapak Ibu, hal yang paling penting adalah untuk menjaga agar tidak terkontaminasi langsung dengan tanah seperti itu. Lalu untuk stabilisasi tanah dasar, sebagai kita ketahui Bapak Ibu, untuk wilayah di Indonesia, ada beberapa permasalahan tanah ya. Ada expansive soil, ada pit soil, ada soft soil. Ini beberapa problem di Indonesia. Lalu, Apa sih akibat dari permasalahan tanah tersebut? Mungkin sering terjadi nih, seperti penurunan setempat, jalan bergelombang, seperti itu Bapak Ibu. Ini sangat tidak nyaman ya, lalu juga berbahaya. Lalu akibatnya dari tanah yang problematik tadi, jalan menjadi sulit untuk dilalui tentu ya, karena tanahnya sendiri itu sangat lunak. Jadi akan menghambat akses dari ketika kita ingin melalui jalan tersebut. Lalu ketika kita akan mengkonstruksi jalan pun itu banyak terjadi masalah nih Bapak Ibu. Salah satunya mungkin Bapak Ibu sering menjumpai nih materialnya jadi lebih sulit untuk dipadatkan. Seperti itu. Lalu biasanya material timbunannya itu akan hilang. Jadi ketika dipadatkan hilang lagi karena dia tercampur dengan tanah soft soil tadi, tanah lunak tadi. Nah, untuk stabilisasi tanah dasar ada Geogrid dan Interact di sini dari Tensar, di mana saya jelaskan untuk yang Interact sendiri, ini sudah yang terbaru ya Bapak Ibu, di mana keunggulannya dia kuncinya adalah di mechanically stabilized layer, di mana kunci utamanya menggunakan interlocking. Jadi sangat mampu untuk mengikat agregat secara lateral. Seperti itu. Lalu tentu saja dia dapat mengurangi perbedaan penurunan. Jadi differential settlement tadi itu tidak akan terjadi. Lalu untuk proteksi terhadap subgrade sendiri. Dan tentu material ini dapat mengurangi agregat pilihan nih Bapak Ibu. Jadi apabila Bapak Ibu sudah mulai berpikir untuk menggunakan geogrid ini sendiri, tentu ketebalan agregat pilihannya dapat berkurang dan meningkatkan umur jalan juga. Seperti itu. Ini ilustrasinya. Lalu mudah dalam pemasangan. Nah, untuk pemasangan sendiri sebenarnya ada beberapa hal yang perlu diperhatikan. Sebenarnya untuk pemasangan seperti biasa ya Bapak Ibu tinggal digelar, sangat mudah sekali. Namun ada yang perlu diperhatikan seperti overlappingnya harus berapa, itu akan disesuaikan dengan proyeknya sendiri. Lalu ketebalan dan jenis timbunan itu sesuai dengan perhitungannya dan pemadatan timbunannya harus dipadatkan dengan baik. Jadi seperti situ. Untuk pengalaman proyek sendiri, ini kami ada stabilisasi jalan akses tambang batu Bapak Ibu menggunakan Geogrid Tensar Tri-X di Tapin di Kalimantan Selatan. Mungkin sering ya kita lihat di lokasi ini tanah-tanah existingnya itu rawa dan sawah Bapak Ibu, sangat lunak. Jadi ketika kita menggunakan ini secara bagus sekali jalan menjadi lebih stabil seperti itu. Bisa terlihat dari foto-foto dokumentasinya. Nah, ini stabilisasi jalan akses Pertamina Aset 2. Nah, ini yang saya perlihatkan tadi sebelumnya, yang dimana sangat sulit untuk dilalui karena tanahnya tanah lunak, Bapak Ibu. Ini ada di Palembang lokasinya. Nah, karena tanah lunak, setelah menggunakan ini dan dipadatkan dengan material timbunan yang disyaratkan, jalannya menjadi lebih mulus gitu ya. Jadi proyeknya sudah tidak terhambat lagi, perjalanannya menjadi lebih mudah. Selain itu, tidak hanya dari produk saja Bapak Ibu, untuk stabilisasi tanah dasar, kami juga mempunyai dukungan teknis dengan software Tensar Plus. Nah, software ini akan memudahkan kita semua, kami, dan ini sangat user-friendly Bapak Ibu, di mana Bapak Ibu juga dapat mempelajari tentang software Tensar Plus, di mana kita biasanya mengadakan workshop-workshop. Nah, di sini akan membahas produk apa yang tepat untuk kondisi proyek Bapak Ibu, ketebalannya seperti apa, material timbunannya, lalu produk yang di requirement-nya seperti apa. Kemudian ada perkuatan lereng dan dinding penahan tanah timbunan Bapak Ibu. Nah, untuk dinding penahan tanah timbunan sendiri, produk yang digunakan adalah Geogrid Uniaxial by Tensar. Jadi dia sebagai perkuatan lereng dan sebagai perkuatan dinding penahan tanah timbunan Bapak Ibu. Nah, dia akan berapa dalam sih, berapa panjang sih kebutuhannya. Tentu ini akan dihitung dan akan disesuaikan dengan kondisi jenis tanah dan jenis surcharge yang akan dibebani selanjutnya. Nah, ini contohnya. Jadi material pembentuk dinding penahan tanah sendiri itu ada 3 aspek utama, Bapak Ibu. Ada geogrid uniaksial sendiri, by tensa. Lalu facingnya akan bermacam-macam yang kami tawarkan. Lalu untuk material timbunan pilihan itu bisa menggunakan tanah merah, limestone, pasir atau granular. Ini disesuaikan saja dengan ketersediaan dan dengan perhitungannya. Nah, terkait jenis facing, ada slope yang bisa digunakan tanpa facing, Bapak Ibu, di mana sudut kemiringannya itu kurang dari 45 derajat terhadap horizontal. Lalu eh, ada facing jenis wrap around di mana menggunakan sandbag Bapak Ibu. Kalau di gambar ini sandbagnya sudah sangat cantik ya, sudah ditumbuhi sama vegetasi, jadi sudah hijau. Di mana sudut facingnya itu di range 50 derajat sampai 75 derajat terhadap horizontal. Lalu ada scape eh, menggunakan welded wire foam di mana sudut facingnya itu bisa di 75 derajat sampai 87 derajat. Jadi hampir tegak lurus nih Bapak Ibu terhadap horizontal. Lalu ada pilihan multiblok Bapak Ibu, di mana sudut facingnya itu bisa di 87 derajat terhadap horizontal. Mungkin Bapak Ibu sering menemukan multiblok ini misalnya di jalan tol gitu ya, di flyover sering sekali, atau di abutmen juga sering. Nah, ini adalah pilihan-pilihan facing untuk dinding penahan tanah timbunan. Untuk pengalaman proyek, ini adalah wraparound, Bapak Ibu, wraparound retaining wall system. Lokasinya di Cariu, Jawa Barat untuk crusher plant. Jadi ini sebelumnya terlihat di gambar ya, sebelum hanya sandbag saja, tentu menggunakan uniaxial geogrid, Bapak Ibu. Lalu setelah beberapa waktu tervegetasi dengan baik, jadi memang terlihat sangat hijau. Jadi memang secara looks itu sangat cantik. Lalu ini untuk yang Sierrascape Bapak Ibu, di mana ini lokasinya di Sumbawa, NTB. Ini untuk Batu Hijau Expansion Project. Ini cukup tinggi Bapak Ibu, dan lerengnya sendiri bisa tegak lurus. Eh, Untuk selanjutnya, itu ada monitoring jarak jauh by INSAR yang mungkin tadi sudah disampaikan oleh Andrew Lis. Jadi untuk monitoring jarak jauh dari INSAR sendiri, sebenarnya keunggulannya itu ada beberapa. Yang saya highlight di sini adalah dia lebih murah apabila dibandingkan dengan in situ monitoring. Tentu ini akan lebih baik apabila di combine ya Bapak Ibu. Lalu lebih cepat karena untuk monitoring ini tidak perlu mob demob surveyor setiap saat gitu ya. Lalu juga tidak perlu ada instalasi alat apapun. Lalu untuk akurasi juga sudah tervalidasi. Lalu ini juga non-destruktif, Bapak Ibu, tidak perlu mengganggu dan menghentikan operasional struktur fisik apapun karena dia dipantau secara jarak jauh. Lalu dia otomatis, jadi otomatis mengumpulkan data pemantauan yang kita butuhkan dan dia sifatnya retrospektif, di mana semua data itu dikumpulkan dapat tersedia dari waktu yang masa lampau sekalipun. Jadi kalau misalnya Bapak Ibu butuh data, oh 5 tahun sebelumnya seperti apa ya, itu juga bisa menggunakan monitoring jarak jauh by INSAR. Jadi keunggulannya apa? Tentu dari aspek geoteknik sendiri Bapak Ibu, kita bisa menginvestigasi lokasi dari prakonstruksi. Untuk pertambangan, kita bisa memantau kondisi aset pertambangan kita, seperti tailing dam, gitu ya, fasilitas penyimpanan air, tumpukan material, lereng, dan infrastruktur pentambangan. Untuk di energi sendiri, kita bisa memantau keselamatan aset infrastruktur energi untuk pipa, fasilitas lepas pantai, dan bendungan. Nah, untuk transportasi bisa menjaga integritas jalan raya, jalan, jembatan, dan jalur kereta api. Ini adalah hal yang sangat mungkin disupport dan dimonitoring dengan menggunakan INSAR. Lalu pertanyaannya, kenapa perlu mempertimbangkan teknologi monitoring jarak jauh dari INSAR, Bapak Ibu? Nah, monitoring ini sebagai pilihan tepat apabila area of interest atau tinjauan dari area proyek yang akan dipantau itu luas gitu. Jadi kalau misalnya Bapak Ibu punya area of interest dan tinjauannya itu lumayan luas, maka teknologi ini sangat-sangat efisien dan sangat baik untuk dipilih. Lalu, apabila ingin biaya yang lebih efisien tentu bila dibandingkan dengan instalasi in situ karena ini akan mengurangi kebutuhan dari instalasi in situ dan surveyornya sendiri. Lalu, ini bisa dipantau kapan saja dan di mana saja, sangat mudah dan user friendly Bapak Ibu. Dan apabila Bapak Ibu ingin mendapatkan output yang tidak sekedar grafik dan angka saja, namun interpretasi dari setiap hasil. Tentu saja by Multibangun yang berpartnership dengan Geofem. Lalu mengapa harus Multibangun? Untuk produk-produknya, kami materialnya tersedia ready stock. Produk kami berstandar internasional, Bapak Ibu, distributor tunggal resmi dari produk-produk berkualitas premium. Dan kami didukung oleh tenaga ahli profesional dan installer yang berpengalaman. Tidak hanya itu, kami juga didukung oleh software yang relevan. Nah, untuk monitoring jarak jauh, by INSAR, kami berpartnership dengan Geofem sendiri, di mana di sini kita komplit Bapak Ibu, tidak hanya GIS saja, di dalamnya juga ada geotechnical expert, ada geohazard specialist, ada remote sensing specialist. Jadi ini sangat komplit kombonya gitu ya. Jadi Bapak Ibu apabila tertarik untuk mengetahui tentang monitoring jarak jauh by INSAR, bisa menghubungi kami PT Multibangun. Baik, berikut sekilas terkait produk dan jasa dari PT Multibangun. Apabila Bapak Ibu mempunyai pertanyaan terkait produk, dapat menghubungi kontak yang tertera ya Bapak Ibu. Lalu Bapak Ibu juga dapat mengunjungi website Multibangun di www.multibangunpatria.com. Lalu terima kasih banyak atas perhatiannya. I'll give it back to Andrew Liz. Well, Andrew, I will stop screen first. Well, Andrew, a lot of question already. And
Yes.
then you can continue for the Q&A session, please.
Okay, thank you, Dwee. Yes, quite a few questions. I will go through them quite quickly. Then I may be able to finish them all before we need to stop. Okay, from Eiling Yong, can I confirm that the green dot in the map is approximately 10 meters by 10 meters for Sentinel-1? That is correct. Yes, that green dot represents the displacement across a pixel about 10 meter by 10 meter. Although it's a dot, it does not necessarily represent that specific location of the dot. It is somewhere within that pixel. Could be an average over the pixel size, or it could be certain objects that are providing the backscatter. So a very bright object that is reflecting the radar may govern the result. Okay, next, Mike Doby. I know him. Is INSAR better for detecting east-west movement than north-south? Good question. Pure north-south movement may not be detected. So if you have that situation where it is you have movement only in the north-south direction, not vertical, then it's not well suited to that. That is an unusual occurrence. If it goes slightly out of north-south or slightly vertical, then it will be detected. That is because of the orbits. The orbits are looking from ascending down and to the east and from descending down and to the west. So you can detect movements in that plane. So anything that's going vertical or east-west can be detected. If there's something going in that direction, it's not going to be detected. So very good question. Later, there will be more orbits added, and north-south horizontal movement will be detectable. Divash Moon Sami, most of the examples given are relatively flat. Are there any limitations on INSAR in terms of aspect and slope angle? There is a limitation. Imagine you have a vertical slope, so a cliff. If we have SAR looking from this direction behind the cliff, it's not going to get any data on this cliff face here. But if you have an orbit coming from that direction, then yes, you will get very good data. So the example I showed with the MSC walls in Fujairah is a good example. That's a bit like a very high vertical face. But by using data from the right orbit, you can get very good data. But if it's not in the right orbit, you can get a shadow effect that we saw in the sinkhole example in Aceh, that you will get shadows. So that's something you need to be careful of. Kevin Mawan, what is the threshold for data noise? If the ground shifts significantly and then stabilizes, can subsequent minor movements within this threshold be considered noise? There isn't really a threshold in that way. The only problem, if you get a very large movement, is you can, if the movement goes more than than a wavelength, then it's not possible for the technique to determine whether the displacement is about a wavelength or a multiple of it, because it's looking at phase difference. So that's why you get the fringes on that interferogram that I showed. So you're getting multiple wavelengths of shift. So that is the main issue there. If you get a fairly rapid rate of movement, but you don't get that issue, then when it slows down, that shouldn't be an issue. You should still get that that movement. Vikri, if there is climate change, does it affect the measurement, and how big is it? If yes, when is the best time to measure, analyze the data? Well, climate change is a very gradual process. So if you're looking at that, it's best to use the full archive of Sentinel data, which goes back 10 years to 2015. I would say you would need at least about 5 years to see some sort of long-term trend due to climate change, but certainly over 10 years. It doesn't cost much more to go all the way to 10 years because the data is free. It's just a little bit more time to download and analyze the data. So well worth using the full 10 years. Ali Ling Yong, for the Pondal Balik Aceh sinkhole, how do we separate the deformation and topography of the sinkhole? Does the topography of the sinkhole changing due to the expansion of the sinkhole? Okay, yes, very good question. It is important to have a good digital elevation model to undertake INSAR. So the DEM comes separately. That is as up to date as possible, but it may not be right up to date. So the SAR data is also used to add some update to the DEM. So that technique is used in the analysis. So if that hole is growing and it's not reflected in the external DEM that's being used, the SAR data that you are using for INSAR can be used to help update that DEM. Mirza Ibrahim, in cities with high-rise buildings, radar signals can get blocked when housing. Okay. First question. Yes, a very good question. You can get shadows, just like we did with the Aceh sinkhole. So you need to be very careful with interpreting that data, particularly when you're looking at it plotted on an optical image from above. Some points are not where they seem. So you might appear to have points in the shadow of a tall building, but actually those points are on the building. So something to be very careful of. How does AI distinguish between routine urban substance and a true sinkhole precursor? That's something that the technique learns. So if we tell it where sinkholes have occurred, it learns what is the urban background movement and learns how to distinguish that. So with a sinkhole, you would expect to see a certain pattern of increasing movement that is, it keeps on increasing rather than sort of in a more cyclical nature. It's something that's just accelerating all the way to sinkhole collapse. From a business point of view, what are the cost benefits compared with the ground surveys? Well, no contest. It is very, very cost effective compared to going out on site using any technique, because you can just do it all from your desk without having to visit the site. Bickery, is it possible to determine the cavities in certain depths by satellite data and create a map of cavities? Not really. No, the SAR doesn't have deep enough penetration. There is longer wavelength SAR that may get to about half a meter penetration, but no, we can't really use it for that technique. You need to use geophysical techniques in situ. Sandy, oh, I know Sandy as well. Hi, Andrew. Thank you for your game. I'd like to ask about the advantages of InSAR monitoring sinkholes. Is it possible for InSAR to detect future displacement? Well, you can look at trends. So if you see a precursor to a sinkhole and you see the rate getting faster and faster, then yes, you can predict collapse, particularly by a technique called inverse velocity. So if you do 1 over the velocity that you're measuring, then the collapse happens when inverse velocity gets to 0. So we've got some very interesting plots of collapses where you see the inverse velocity getting closer and closer to 0, and then you can forward predict the collapse. So we've done that successfully on some tailings dam failures. That's a technique quite often used on tailings dam monitoring. Mirza Ibrahim, from a contractor's perspective, can this technology be applied to establish a multi-year historical displacement baseline for a site prior to construction in order to safeguard against litigation? Yes, certainly you can. Yeah, it's a very good site investigation tool before construction. Very good idea to get baseline background movements to see any effect caused by the construction activity. Has it changed anything? It's a very good point. Yes, the ground movements could have been occurring before construction started. Mohammed, I'm not following. May I ask in the aperture section, how does aperture size affect sign detect small fish as sinkhole precursors? Well, there's a direct correlation between the spatial resolution and the size of the sinkhole that you can detect. So with the free Sentinel-1 data with about 10 meter by 10 meter spatial resolution, you would think that the sinkhole needs to be about 10 meters across. Well, certainly the settlement created by it. In the example I showed in South Africa, the eventual hole in the ground was pretty small, only about a meter across, but the settlement signature was about 50 meters across, was it? So it was detected quite easily. So certainly the better the spatial resolution, the more likely you are to detect smaller sinkholes. The big sinkholes are the ones that we really need to be worried about. So it's certainly useful to be able to detect the big ones. For Wawan, particularly related to data coherence. How can this be done to obtain reliable data in rural areas? Yes, rural areas are more challenging. There are different analysis techniques to help overcome that. So there are non-linear analysis techniques that work better in rural areas than the more basic linear techniques. So that's one thing that you can do. Another thing that can be done is maybe to use different wavelengths SAR. So the Sentinel-1 data uses C-band. That's a good. Actually, let me explain X-band and L-band first. X-band is quite short wavelength, works very well in urban areas, and you get good spatial resolution. You have L-band, longer wavelength, It would work in urban areas, but you don't get such good spatial resolution. But it works well in rural areas, also even in forest areas, because the wavelength penetrates through the vegetation and you get data from the ground. The C-band from Sentinel-1 is in between, so it's a good all-rounder. It will give you reasonable spatial resolution in urban areas, but also give you data in rural areas, but not as much. So that's why the C-band from Sentinel-1 is a good compromise. L-band is now available free. Recently, the NISAR satellite was launched. That's been recording data for about 9 months. That's just coming on stream. So we will have a better option, or we have one now, just starting for rural areas. Is there any step-by-step training of the using INSAR and how can we integrate it into QGIS Sentinel-1? I can't really answer that, sorry. Maybe there is. I'm sorry, I don't know. Are the processing steps for L-band identical to C-band? Are there any different processes? So there's a bit of a difference in the pre-processing, but broadly INSAR is the same, regardless of the band. The next one, I'm going to need a little bit of help with that one. So maybe Dwi, you can help me with that one at the end if we have time. From Putu Edi Stiga, how do you overcome the limitation of spatial resolution started for sinkhole precursors and limitations such as low current in the vegetative? I think I've answered those already in the earlier questions. As mentioned, the stage one involves slightly acidic rainwater. What indirect parameters can satellites detect at this stage? Yes, the ground subsidence and the changes in soil moisture are the main ones. The other parameters are you could obtain those from other sources. So you wouldn't need to obtain that from satellites, such as the geology, the pH of the soil, the precipitation, maybe the acidity of the precipitation, and flow accumulation. Those could all be obtained independently. And the last one again, that would need to be translated. So that brings us to the end. Thank you very much for all those questions. I see, Dwi, you've been busy answering them in text. Okay, brilliant. Thanks for that, Dwi.
Yes, but maybe for the last questions, not yet, Andrew. Do you need me to translate the last questions? So
Yes,
she asks about this. Is it satellite can give like some early warning, and then can we know precisely when the possibility sinkhole will be happened? And then she asked about what is the factor is affect the lifetime after we improve or we treatment the soil after the sinkhole. So the factor of can be effect of the lifetime after we improve the sinkhole. Actually, I'm not clearly understand about these questions, but for the satellite early warning, I think you can answer this.
yes, there is a potential for satellite data to certainly provide early warning and potentially to predict the time of collapse. If we see an acceleration, we can use a technique called inverse velocity. So when you reach collapse, inverse velocity becomes 0. So you can, I wish I had an example ready and I could show you with these examples where we have predicted collapse. Not in a sinkhole specifically, but in tailings dams where you look at the data and you see it's getting closer and closer to 0 and you
To the failure.
predict to where that's going to become 0, and it works pretty well for those cases that we've looked at. But of course, you can't rely on that. The big advantage of INSAR for sinkholes is just identifying a possible precursor. Then you can investigate further. So you can make the area safe, then perhaps use some geophysical techniques at that location. The problem with sinkhole prediction is if you have a large area of geology that is susceptible to it, so a large area of limestone, the sinkhole could be anywhere. And it's very difficult to use in situ techniques to do the whole area. Imagine doing geophysics across hundreds of square kilometers. That will cost a fortune. So satellites are really good at covering large areas. They may not find all the sinkholes, but they might find some, and that is still very valuable. And then the next stage is the sinkhole susceptibility assessment, the algorithm that we developed that combines other data with INSAR, and that is going to tell you where the sinkholes are most likely to occur. So if you wanted to control the risk, you could focus your in situ surveys using geophysics and borehole techniques in those more susceptible areas where we think you are more likely to detect cavities and potential sinkholes before they are activated.
Well, thank you, Andrew. Untuk Bapak Rizky, mungkin dan lain-lain pertanyaannya akan kami rangkumkan dan akan kami jawab, kami translatekan nanti. Bisa menghubungi WhatsApp yang sudah saya type di question and answer feature ya, Bapak Ibu. Terima kasih. Thank you, Andrew. I will give it back to Rifa.
All right, so thank you, Mbak Dwi, and also Dr. Andrew. Thank you very much for the highly informative webinar on identifying sinkhole precursors and assessing collapse risk using satellite data and AI. Your presentation was clear, and thank you for your valuable knowledge shared with all of us and your support to Multibangun Engineering Hub. Baiklah, bila Bapak, Ibu masih ada pertanyaan, terutama terkait produk INSAR yang baru saja dipresentasikan oleh Andrew maupun geosintetik lainnya dari Multibangun, bisa langsung menghubungi kami via WhatsApp di 0811 2801 4141. Baik, Bapak, Ibu, dan rekan-rekan sekalian, kita akan beralih nih ke sesi selanjutnya, yaitu kuis berhadiah. Kuis berhadiah ini nanti akan dipandu oleh rekan saya, Tanti. Bapak Ibu, saya informasikan bahwa kuis ini boleh dimainkan oleh semua peserta yang hadir di Zoom ini, tetapi hanya peserta yang tinggal di Indonesia yang eligible untuk memperoleh hadiah dari kuisnya. Baiklah Bapak Ibu, tanpa berlama-lama lagi, kepada Tanti, saya persilahkan.
Selamat sore Bapak Ibu sekalian, perkenalkan nama saya Tanti dan saya hari ini akan memandu kuis. Baik, masih pada semangat gak nih Bapak dan Ibu? Walaupun memang jam-jam segini jam-jam kritis ya, apalagi di masa puasa jadi lebih letih lesu, tapi nggak apa-apa, ini saat yang tepat untuk asah fokus lagi ya. Jadi mana tahu nih rezeki hari ini datangnya dari kuis Multibangun. Oke, sebelumnya saya akan menjelaskan terlebih dahulu. Jadi nanti akan ada 5 pertanyaan, di mana 3 pertanyaan ini pertanyaan dari presentasi kita, Andrew Lee, dan 2 pertanyaan dari Mbak Dwi selaku marketing Multibangun. Nah, untuk total hadiah kuis ini berjumlah Rp750.000 untuk 3 pemenang, di mana juara 1 akan mendapatkan e-money sebesar Rp300.000, juara kedua mendapatkan Rp250.000, dan juara ketiga mendapatkan Rp200.000 dalam bentuk e-money. Saya ingatkan untuk nanti jangan lupa untuk menuliskan nama sesuai dengan nama ketika Anda register untuk webinar ini. Dan jika nanti Anda mendapatkan juara, harap di screenshot dan dikirim ke WA admin Multibangun. Oke, sudah siap ya Bapak dan Ibu sekalian? Tanpa berlama-lama lagi, langsung saja ke browser HP ataupun laptop. Dan lalu ketikkan www.menti.com. dan masukkan kode 89690663 atau boleh scan di sebelah saya. Oke, kita lihat udah berapa player yang masuk ya. Oke. Ayo Bapak Ibu, mumpung mendapatkan hadiah, boleh join menti.com dan masukkan kode 89690663. Oke, sudah banyak yang masuk ya. Kita tunggu. Wow, sudah. Oke. Kita tunggu sebentar lagi ya. Oke, ada yang mau join lagi nggak nih kira-kira? Coba kita tunggu kira-kira berapa player nih. Oke, kita mulai ya. Dari 5, 4, 3, 2, 1. Oke, pertanyaan pertama. Jawab cepat ya Bapak Ibu. Approximately, what is the spatial resolution of the free data from the Sentinel-1 SAR satellites? A, 1 kilometer by 1 kilometer. B, 100 meter by 100 meter. C, 10 meter by 10 meter. D, 1 meter by 1 meter. Ayo, kira-kira jawabannya apa nih ya? Apakah 1 kilometer by 1 kilometer? Benar, jawabannya adalah 10 meter by 10 meter. Kira-kira siapa ini yang mendapatkan posisi pertama? Boleh ditunjukkan? Baik, yang tercepat yang pertama itu Teguh Kristianto Simbolon ya, diikuti oleh Kevin Dermawan. Yang ketiga Ceko. Baik, berlanjut ke pertanyaan selanjutnya. Which of which of the following is not a causal factor in sinkhole formation? A, soil pH. B, precipitation. C, geology. D, spatial resolution. Apa ya jawabannya ya? Kira-kira nih. Ayo jawab cepat ya Bapak Ibu. Apakah jawabannya B? Yes, jawabannya adalah spatial resolution. Kita lihat apakah yang pertama masih Bapak Teguh? Wah, yang tercepat adalah Kevin Dermawan. Oke, next question. Which of these rock types is most susceptible to the cavities that cause sinkhole? A, limestone. B, sandstone. C, clay. D, volcanic rock. Oke, jawabannya adalah A ya, Bapak Ibu, limestone. Kita lihat siapa yang tercepat yang masuk ke pertama nih. Yes, masih Kevin Dermawan ya, diikuti oleh Teguh. Dan yang ketiga, kambing guling. Oke, next question. Di bawah ini, mana yang bukan keunggulan dari INSAR? A, akurat. B, retrospektif. C. Otomatis. D. Slow motion. Apakah jawabannya D atau A? Ya, benar. Jawabannya adalah D. Slow motion. Kita lihat apakah masih Kevin Dermawan. Kita lihat dulu. Oke, kayaknya masih Kevin Dermawan ya. Dan yang kedua Teguh Kristianto. Tapi ketiga nih ada Joni. Kambing guling kemana? Oke, pertanyaan terakhir nih, Bapak Ibu. Jawab cepat ya. Mengapa monitoring jarak jauh ini lebih efisien? A. Karena dapat mengurangi instalasi sensor in situ. B. Karena dapat mencakup area yang sangat luas. C. Karena dapat dipantau tanpa harus ke lokasi. Atau D. Semua benar. Yep. Jawabannya adalah D. Semua benar ya Bapak Ibu. Oke, kita lihat siapa nih juara pertamanya. Baik, juara pertama ada Teguh Kristianto Simbolon, dan yang kedua itu Rahajeng, dan yang ketiga adalah Irma Dwi Amalia. Baik, selamat kepada para pemenang dan terima kasih kepada Bapak Ibu yang sudah mengikuti kuis pada hari ini. Saya Tanti, saya pamit undur diri dan saya kembalikan ke teman saya Rifa. Terima kasih.
Baiklah, selamat kepada para pemenang dan jangan lupa untuk screenshot dan mengirimkan buktinya ke admin WhatsApp Multibangun ya. Mohon maaf nih tadi kalau ada kesalahan teknis sedikit. Saya juga mengucapkan terima kasih banyak kepada Bapak dan Ibu yang sudah ikut berpartisipasi dalam kuis Multibangun hari ini. Akhir kata, sebelum itu ada pengumuman ya, untuk informasi mengenai sertifikat dapat diakses melalui link tr.ii/mrp webinar yang juga tertera pada kolom chat atau yang tertera pada layar Anda. Apabila Anda memiliki pertanyaan atau terdapat kesalahan penulisan nama pada sertifikat Anda, silahkan hubungi saya Rifa melalui WhatsApp di 0812801441. Baiklah, untuk informasi lebih lanjut terkait PT Multibangun Rekatama Patria dan acara-acara kami selanjutnya, Bapak Ibu bisa mengikuti media sosial kami, ada LinkedIn, Instagram, TikTok, YouTube, dan Facebook. Jika Bapak Ibu ingin mengetahui seluruh produk dan jasa dari Multibangun, bisa menghubungi website kami di www.multibangunpatria.com. Baik, selain itu, untuk melihat tayangan ulang pada hari ini juga bisa mengunjungi YouTube Multibangun. Bapak Ibu akan disuguhi video informatif, edukatif, dan tentunya seru terkait dunia konstruksi khususnya geosintetik. Akhir kata, saya, Rifa, mewakili segenap panitia mengucapkan terima kasih kepada seluruh peserta, pembicara, dan panitia yang terlibat dalam acara ini. Saya juga memohon maaf jika terdapat kesalahan teknis, kesalahan kata pada penyampaian selama acara berlangsung. Kami menunggu Bapak Ibu di Multibangun Engineering Hub webinar selanjutnya di bulan-bulan mendatang. Saya Rifa, pamit undur diri, selamat sore, dan sampai jumpa. Mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa. Dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan dalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman industri mengenai aplikasi geosintetik yang lebih luas, mendorong inovasi dalam pengembangan konstruksi dan infrastruktur yang lebih efisien dan berkelanjutan, serta membangun koneksi yang lebih kuat antara mahasiswa dan profesional melalui kesempatan jaringan serta pengalaman belajar secara langsung. Melalui kolaborasi antara teori dan praktik, Multibangun ingin memiliki andil dalam memberdayakan semua lapisan stakeholder yang terdiri dari insinyur, kontraktor, hingga calon pemimpin industri untuk mengintegrasikan teknologi geosintetik dengan lebih efektif dalam setiap proyek yang mereka kerjakan. Jangan lewatkan setiap event yang Multibangun Engineering Hub adakan dan bersama menciptakan solusi rekayasa yang lebih cerdas, berkelanjutan, dan inovatif. Setelah sukses mengadakan workshop dan webinar pada beberapa tahun sebelumnya dengan antusiasme dan testimoni yang luar biasa, dengan ini kami mempersembahkan Multibangun Engineering Hub. Multibangun Engineering Hub adalah sebuah program terbaru dari PT Multibangun Rekata Patria yang berfokus pada pengembangan pengetahuan dan inovasi di bidang geosintetik. Program ini menyediakan berbagai kesempatan edukasi dan jaringan untuk meningkatkan pemahaman serta keterampilan para mahasiswa dan profesional melalui berbagai aktivitas, antara lain webinar yang terbuka untuk umum dengan topik seputar geosintetik dan aplikasinya yang relevan dalam industri. Workshop dirancang untuk para profesional memberikan pelatihan teknis mendalam serta pengalaman praktis yang dapat diterapkan langsung pada proyek yang relevan. Multibangun Goes to Campus adalah program khusus yang menghadirkan kuliah tamu dan workshop yang dirancang khusus untuk mahasiswa teknik sipil menghubungkan dunia akademik dengan wawasan industri. Dengan menghadirkan sesi yang diisi oleh para ahli, studi kasus nyata, serta diskusi interaktif, Multibangun Engineering Hub bertujuan untuk meningkatkan pengetahuan dan pemahaman